This project is actually a cooperation with ABB Corporate Research. Our supervisor is Todd Benosen. And basically, for most people, maybe you know that in the traditional conventional partial discharge measurement techniques, we only use technique to detect the fast PD events to record PD numbers and amplitudes. Where in this case, in this project, we try to study the PD activity by using the dielectric response measurement technique. By means that is actually measure the current generated from the PD activity and try to integrate this current. So with this technique, we can actually integrate both fast and slow current from the PD activity. This current basically is the difference between the current measured with voltage below the PD inception and above the PD inception, the difference between these two currents. So we can actually see the current contribution from the PD activity. This system, actually measurement technique, your system have two techniques. To the left is our system realized by AVIS technique, where we can use any repetitive voltage waveforms to use Fourier transform and then to calculate the current from the frequency domain and via the time domain, frequency domain, and come back to time domain. And the other system you can understand as a conventional PD detection system, which was also developed within the group by my colleague Thomas Armstrong. His project was also belongs to former Elektradagen project with the same setup. With these two systems, we can actually measure the PD activity simultaneously, both from voltage side as well as from the current side. The first example we showed here is measure the PD activity from the corona needle plate electrode, where we increase the voltage with 3 different voltage levels. We can see the PD activity actually from negative half cycle, the amplitude reduces, but the density increases, whereas also appears to, from the positive half cycle, have some occasionally big PDs appear from the positive half cycle, where if we can compare it with our new method with excess current measurement, we can see the increase of the voltage, we can see the current was increased and the negative half cycle. Also, the current, discharge current start to appear from positive. In this example, we can see, okay, we can use PD excess current to compare many small PDs against a few big ones. So you can quantify them by using the same current factor. Later on, we use this technique to study the PD activity over the long time, where we can integrate every half cycle into the one integrated excess current, and then that number should be able to compare it with the PD activity registered by the conventional method with the sum of the PD numbers and amplitude from the same half period, where we actually observe the PD activity decrease, even disappearance of the PD activity due to the contributions from the additional preceding PD excess current that actually move around the test object to suppress the PD activity. This is one example we showed in the twist pair, where at the beginning, the first time, both register PD activity as excess current, they are matched quite well. But with time goes by, with a longer time measurement, the PD activity actually reduces due to the contributions of the additional current that happened before the PD activity, which means those are space charges which move before PD appears to modify the electric field and reduce the PD amplitude. Eventually, later on, it's stabilized with integrated slow current where the PD activity disappears. And another example we showed here is actually PD activity oscillations in the cavity, where the dynamic changes of the integrated excess current compared with PD activity oscillates. It also shows with the increase of the integrated excess current as the decay of the PD activity. Later on, we believe that those measured PD excess current exists in the air. So we took an air tube with samples inside where we can control the air flow through the test environment. In there, we actually shows before we put any air inside, PD activity reduces with increase of integrated excess current. But once we blow the air through it, the PD activity goes back. And to the almost same level as we integrate total current. But when we start off the air, the PD activity reduces with a steady state total current. But once later on, when we reduce the voltage level, PD activity disappears, but we still can measure the additional current due to proceeding current. But once we turn on the fan again, where is this shadow area, the total measured additional current disappears. So we believe those additional current we measured from the preceding PDs actually was acting in the surrounding airs and modify the electric field around the samples. So to conclusion this of the project is actually PD excess current we developed in the group is a very good complement to the conventional PD detection method. Then the PD activity variations is between the PD time development, in the PD time development measurement is actually interplay between the additional current as well as PD activities. And yeah, that's.
I think we need to move on. So.